Wow, we're in chapter 11, geometry, and today we get to kind of review some things that you are very familiar with respect to solid geometry. So pause your video and answer these questions. Come back and check your work. A polygon with 3 congruent sides, equilateral triangle. How about 6 congruent sides and congruent angles, regular hexagon. And finally, a polygon with 4 sides and with opposite sides parallel and congruent, a parallelogram. Remember this word regular. What does that tell you? That's right, that all sides of the polygon are congruent. So today we will classify three-dimensional figures according to their properties. We'll also use nets and cross-sections to analyze three-dimensional figures. I think we have used all terms here in pre-algebra. Cross-section may be the one term we haven't used. All but that one, right? Face, edge, vertex, prism, cylinder, pyramid, cone, cube, net. So cross-section is something that we didn't use much in pre-algebra. Let's slowly think about this figure. Three-dimensional figures, or solids, can be made of flat or curved surfaces. Each flat surface is called a face, right? What is the segment that is the intersection of two faces? So where two faces meet along here is the edge. Good. And a point that is the intersection of 3 or more faces, so look at the top, the front, and the right side here meet at this point, we would call that a vertex. That's right. So we could say that's a face, we have an edge over here, and then this dot represents the vertex, the point where all 3 edges meet. Here are examples of three-dimensional figures. So what kind of figure has 2 parallel congruent faces, called bases, that are connected by faces that are all parallelograms? And that is called a prism. I hope you have that. We talked so much about that, didn't we? And this is like a prism. This has 2 parallel congruent bases that are circles though, right? And a curved surface that connects the bases. And this is a cylinder. And we have a figure that has a polygon base and triangular faces that meet at a common vertex. And what do we call that kind of figure? Good. Pyramid. And finally, we have this figure which has a vertex opposite a circular base, but it has kind of a curved surface that's lateral, and we call this a cone. So what is a prism with 6 square faces? 6 square faces? That special prism is a cube. Other prisms and pyramids are named for the shape of their bases. So we have, in this case, the opposite congruent parallel sides are triangles, so it's a triangular prism. Rectangular prism. Rectangular prisms, any side and its opposite side could be considered a base, right? We have a pentagonal prism, so the 2 congruent opposite bases are pentagons. Hexagonal prism. And I think the pyramids are really easy to name because we know that the side where all of the triangular faces meet is the vertex, so opposite it is the base. So we name them by their bases. Here's a rectangular pyramid, pentagonal pyramid, hexagonal pyramid. So classify the figure, name the vertices, edges, and bases. So in this figure we have a cube, and the vertices are A, B, C, D, E, F, G, H. So each letter you see is representing a vertex. The edges are many too, aren't they? We have A, B, B, C, C, D, D, A. We can go around the opposite, the bottom here, EF, FG, GH, HE. We also have these edges that are vertical. So we have GH, I'm sorry, HE. We already got those, didn't we? There it is. We have AE, BF, CG, and DH. And our bases here could be any of the 6 faces and their opposite clone, right? Classify the figure, name the vertices, edges, and bases. Pause and come back and check your work. And you should have a pentagonal pyramid, vertices, edges, and the base here is a pentagon. And you can start at any vertex and just name consecutive vertices as you move around it. You can move around it clockwise or counterclockwise. Classify the figure, and the figure here is a cone. Vertex is a single vertex, N, right? Edges, there are none. There are no polygon sides, right? We have a curved side, so no, none. The base, though, is circle M, right? Circle M. What do we call a diagram of the surfaces of a three-dimensional figure that can be folded to form the three-dimensional figure? Recall we did this in pre-algebra. We folded a lot of different diagrams into 3D figures, and we called those nets. Those are a net, right? To identify a three-dimensional figure from a net, look at the number of faces and the shape of each face. So what three-dimensional figure can be made from this given net? Well, the circle is a big giveaway, isn't it? And then we have this, what appears to be a half circle. So if we were to form them into a 3D figure, we would have a cone. This net forms a cone. Cones have circle bases, and then they have parts of, semicircles for their lateral surface area, right? A half a circle there. Describe this 3D figure that can be made from this net. And what do you have? Good, you should have a triangular pyramid, right? The base is a triangle, and then we fold those sides up, and we end up with a vertex opposite the base. The intersection of a three-dimensional figure, imagine a 3D figure, and a plane intersecting with it is known as a cross section. So here we have a cross section. And when we think about this plane cutting through this cone, the cross section here is a point. It's crossing just at the very vertex of the cone. Imagine we could lower that plane and have it, let's say, cut through the cone here somewhere. And in that case, the cross section wouldn't be a single point, but it could be the points that would create what shape? And hopefully you're saying circle, right? Let's look at this. This is a 5-sided base, so it's a pentagonal pyramid, right? And so this cross section, imagine cutting right through the pentagonal pyramid, forms what shape there on the plane? It's a pentagon. Smaller, similar to the base. This is a different way of cutting a cone, right? This cross section that's kind of, I guess, it looks vertical here, right? Forms what shape? And we could say it forms a triangle. Isn't that cool? How the cross section of a cone could be a triangle. Imagine a piece of cheese, like kind of the classic cheese you see in a cartoon. Could be made in the shape of a prism, right? Prism with opposite parallel bases that are congruent. Equilateral triangular bases. So how can you slice the cheese to make each shape? How could you slice it to make an equilateral triangle? Take a cross section, right? Cut parallel to the bases, and you will have an equilateral triangle. We could take that same block of cheese, that same prism, and how would we cut a rectangle? Notice this cross section. And we could simply go perpendicular to the bases and look at, we have a rectangular cross section. If you pause and write your answers down to the lesson quiz, come back and check your work. This figure is a triangular prism. Vertices, we have edges and bases. The bases are really important. They are the opposite, parallel, congruent planes, or faces, right? So, triangles. Describe the three-dimensional figure that can be made from this. And remember to name it. This is called a square pyramid. If you said rectangular pyramid, you know, maybe it's not evident that these sides are congruent. They should give us some symbol or something, right? And what does this cross section form? This cross section, kind of interesting, huh? On a pentagonal prism, forms a rectangle. There you go. Have fun.